So we're gonna go through question 7 from November 2017. It's a grade 10. So they say dolphins communicate through the emission and reception of sounds. So a young dolphin was separated from its mother and it started whistling at a frequency of 130 kilohertz. So first thing you must know is that your 130 kilohertz, that's going to be a frequency, and you must state it in hertz. So you must take it to its SI units. So that's going to be 130, and you're going to multiply it by 10,000. I'm sorry, by 1,000 in order to get it in hertz, because it's kilohertz now. So you're going to have 130,000 hertz.
Multiplied by 1,000. Okay.
So you're gonna have 130,000 hertz. So already you have your frequency. Then the next question is, to call the dolphin's mother. The speed of sound in water is it's 1,480 meters per second. So now you have your velocity, which is the speed of sound in water. So that's 1,480 meters per second. Let me just undo that. Second. So after that, they say explain the term ultrasound. As you remember, I'm not gonna go through definitions because I think like that's gonna take our time. So now they want us to calculate the wavelength of the young dolphin's whistle. So they gave you the frequency and they gave you the speed. They want you to relate it to the wavelength. So if you remember the symbol for wavelength, that's going to be lambda, which we have to find. So we're going to go to our question paper, go to the formula sheets, and look for an equation that has frequency, velocity, and lambda, and the wavelength. And here it is. So it's just straightforward. You just say your velocity is equal to your frequency multiplied by your wavelength. Now, just for stating this equation, it's a mark. And for converting the frequency, it's another mark. So you have to show your conversion. And if you want, I mostly prefer that you make the variable you're looking for the subject of the formula to make it easy for you. Because like substituting and then manipulating the values, sometimes you can get the wrong answer, or your units might be a bit off. But if you directly substitute, it's a bit easier for you. So from that, you're gonna know that your wavelength is gonna be equal to, you're gonna divide both sides by the frequency. It's gonna be equal to your velocity divided by the frequency. So now you're gonna have 1, 4, 8, 0 being divided by 13,000. 13. Oh yeah, 130,000. I'm sorry. 3. So if you want, like, it's not necessary for you to state the units when you're substituting, but if you want, you can just state the units. So let me get my calculator here. So I'm gonna have 1480 divided by 130. 31 to 3,000. Cool. So I got 0.011 what, but you can just leave it at 0.01 meters because that's gonna be a final answer. So yeah. So you know that your velocity is in meters per second, your frequency is in per second. So from that, if you know that the per seconds are gonna cancel each other out and you're gonna be left with meter. So your wavelength is in meters, that's gonna be 0.01 meters or 1 times 10 to the exponent -2 meters. So they say another dolphin hears the distress call of the young dolphin 2 seconds later. How far apart are the two dolphins from each other? So when they say another dolphin is gonna here's this dolphin 2 seconds later, we know the speed of sound and we know the time it takes. So now what we have to find is the distance. So you can say your velocity is also equal to the displacement divided by, sorry, the change in displacement divided by the change in time. So now you're gonna have to, change in distance divided by change in time. So now you're gonna have to find your change in distance. So the displacement, how far away from each other are they? You cross multiply, you're gonna find your change in distance to be your velocity multiplied by the time it takes. So that's gonna give you 1,480, and you're gonna multiply that to 2 seconds. Then I think then you get your final answer as 9 148 times 2. Yeah, 296 2,960 meters. So so in this case, the other mark, because it's 3 marks, so you're gonna get 1 mark for this, 1 mark for this, and a mark for this. The final mark, you have to state that the final mark is for you. It's for you stating that the two dolphins are 400 to 960 meters away from each other. So this statement also sometimes carries some marks. So what I usually do when it comes to like math and science, I always give the final statement just in case, because you have to show that you answered the question. Your calculations don't show that you answered the question that was being asked. So now they ask you to describe how dolphins use echolocation to hunt their prey.
What did we say about 7.4?
7.4. Oh, sorry. So they say the speed of sound in air is 340 meters per second. And they want you to explain why the speed of sound in air is different from the speed of sound in seawater. So basically, from what I can observe, these are two different mediums for sound to travel. So even the densities of the two mediums are different. So I think the most important answer is just that you can say the density of air is different from the density of seawater, or you can just say air and seawater are two different mediums, so sound will not travel at the same speed in each because they have different properties, water and gas. Those are two different things. So you can just say they have different physical properties.
Yeah.
And now they want to know how they use echolocation to hunt their prey. Honestly, I have an idea. I just don't know how to explain it to you. So basically, echolocation, let's say, whatever, the circle here, it's our dolphin. So it's gonna emit a sound. And that sound wave is gonna grow bigger, Like you remember when you threw your stone in water, like it's gonna have like waves that
They go afterwards, yeah.
So this is basically like echolocation. So this is the dolphin, and let's say here is your prey. So you see, dolphins use this emit sound, and where the sound is disturbed or where the sound hits something, because all these other waves will travel uniformly, but this one here at this particular place, there's an interruption. There's something interfering in the motion of the waves. So as they emit their sound waves, where there's that interruption, that's why the prey is. So emit their waves, and the fish is there. It's gonna get in inside the wave field, and when it's there, the dolphin can now sense that, oh, this side there's something interrupting the waves moving. So that means there's food this side. There's something like bigger this side that might attack me. So that's how like the echolocation works. But I'm pretty sure like if you go to like National Geographic, like it's explained a bit better than how I'm explaining it. Yeah. So I don't know. You can just watch like a dolphin documentary. You can go on YouTube. Maybe I can send you a link even if you want. But should I send you like a link now?
No.
It's fine.
To watch the video or what?
Yeah, maybe I can send you a link to a YouTube video. Then you can watch it on your own time.
Oh yeah.
Yeah. So since we still have more than 10 minutes left, according to Zoom, because it hasn't given me that one yet. So let's go through our next question.
Okay.
Yeah. So how about we do this now? Let me just do